Sorry, what?
Have you guys joined newly? Have you attended this session before?
No, no, no. I just attended a session 2 days prior, the info session, and this is my second session. Yeah.
Okay, we'll start. So today we are going to see some questions. So let's start with very basic question. Is that let's say uh, we are given an array, okay, uh, something like 1, 0, 4, 3. This is our array, and we also will be given a target. It's 7. So we need to tell, is there any two element in this array that whose sum is equals to 7, whose sum is equals to 7. So according to this input, can anyone tell what will be the output?
So, are we printing the indexes or the
No,
list?
like we need to just print true and or false.
Yeah. So true. True will be the output. Yeah.
Yeah, it's true. Yeah.
True. Fine. If I say target, we need 8. Will it be true or false?
False.
Yes.
A sum of two numbers, or it can be any number, any type of number. Only two numbers.
Yeah, sum of only two numbers.
Only two numbers. Yeah, it's false then. Yeah.
So can let me take one more example. Yeah, now tell.
True.
True.
True. And if first this output,
Yeah. False.
got it, right? Question is clear right now.
Yes.
Okay. So can you tell me how we can solve this question?
So I'm thinking of a brute force approach right now, back of the mind. So we have two for loops. So the first for loop will start with the first element, and then another for loop will start with the I plus one, and then we'll add both the element. We have a counter sum equals, and we have a target, right? If sum equals to I plus j being this counter of the second for loop equals to the sum, then we have our boolean equals to true, and we break the loop. If it's not equals to the target, then we'll have our boolean set to false. So we'll have return to the uh, return the boolean to false here. So yeah, so that's what I'm thinking right now. It's a brute force approach, O n square, but yeah, that's come to my mind.
Anyone else? That's correct. That's correct. Great. So let's suppose something. This is the signature of my array. We are also giving you and the size of the array, and I am also giving you the target. Now, according to you, what we are going to do is that we are we will be running a loop from 0 to n minus 1. Okay? For j 0 to n minus 1. Sorry, not 0. It will be I plus 1.
I
Correct? Okay. Now what you are doing? Temporary sum equals to array of I plus array of j. If temp sum is equals to your target, you are returning true. Otherwise, if you are not hitting this condition, after this outer value ends, you are returning false. Correct? Is this what you are doing?
Yeah,
So the time complexity will be order of n square.
yeah.
Uh, this is the time complexity. And what is the space complexity?
Space complexity. I think we are not
Constant,
making a
right?
new array, right? So constant, yeah, O of one, yeah.
Okay. Now let's talk about like can we optimize this by something?
Yes, I also know one dynamic uh, programming approach. So I'm not sure if it works or not, but I don't know. Just let me know, okay?
Mhm.
So
Just let me.
we would have one variable int variable designated equals to. So I'm using I'm thinking in Python, okay? So I'm not sure about Java or C++, but right now in Python. So we'll have some, or sorry, maximum. uh, Max is the function, right? So max, in which we'll provide uh, inside one for loop uh, the current index, that is the current value of the index, so 1, and the maximum value, right? Max equals to max of current value index of 1 and the maximum value. And then
Mhm.
uh, we'll have another variable sum. Sum would equals to sum of max plus the current value of the list. So right now in which index we are. And then we'd have a conditional statement which would equals to if sum equals to the target, uh, then we'll break the for loop, and then yeah, we'll break the for loop, and then what are the bool is there. So I think we can bring it out to O of m.
What you will be doing, you will be creating some kind of max variable.
Mm. Max of
Max of
oh sorry, no, just okay, I'm gonna just type it in here if that's okay.
yeah, yeah, you can tell also. I will be writing with you.
Okay, so let's say sum x equals to sum. Yeah, sorry, not max, because we are just getting the summation, right? Sum x equals to sum of inside one for loop, okay? Of the current value. So I, let's say I at that point would
Okay, okay.
be
Basically, we are running. Yeah, yeah, tell me like this. Like we'll be running a for loop.
okay for
Something.
loop for I in array, for I in ARR. Okay, yeah, yeah, you got it.
Yeah.
Okay,
Now,
um, yeah, that's okay. Yeah, go on.
yeah.
And then
Now,
we do
current
uh,
value
current
will
value
be
equals to
array of I.
array of one. Yeah, perfect. Uh, but now sum, we already initiated the variable to some value, let's say equals to 0, right?
Yeah, yeah.
Sum
It's
x, yeah,
done.
yeah, yeah, okay, it's done already. So sum x, so sum equals to
Some plus equals to or equal just equals to.
just equals to just equals to I think there's a function add or sum in Python. I can't remember. There's a function which adds both. It passes two parameters which are integers.
Mhm.
uh, okay, so it's sum or add, you can use any. uh, so use any of the
Basically,
function.
it uh, like keep on adding.
Mm.
Okay, so I can do something like this. Sum plus equals to what the current value.
Current value. Okay, yeah.
Okay, now
No, no. I'm not keep on adding it. I'm just keeping the hold on a minute. Let me just think it right. Sum equals to add. Just a minute. Sum equals to sum. Is there a sum? No, no, no. Sorry. This won't work because I think
correct.
what I'm doing, yeah, what I'm doing is wrong. Yeah. Because I won't get
So let me tell
7
you what we
zero
can
four.
do.
Yeah.
So basically we need two elements, right? Element 1 and element 2 should be equals to k. Now let's suppose we are pointing to element 1. Okay, right now we want to find for element 1 is element 2 is present or not. So what will the like respective value for element 2? Like when we are pointing, let's say at element 1, we will be looking for e2. So what will the value for e2? E2 is nothing but k
A minus E1. Yeah.
minus e1. So we need to look for if we so far have made e2 or not. If we have made e2, then we have a pair, else we don't have a pair. Correct? So what we can
Yeah.
do, uh, so we can have some kind of set, okay, some kind of set. So for I is 0 to n minus 1, let's say e1 equals to a of I, and e2 will be a minus e1. If okay, what this set is holding so far which elements I have seen so far. Now e2 in set it will check. Have it will be like have I seen e2 so far? If it is false, then we will be try for next element. But if it is true, we will be return true. And after this outer loop ends, we will be return false. Let me show you like 1, 0, 4, 3. So set is having no elements right now. Let's talk about 1. 1 is e1 is 1. For this, what will be the e2? If my target is 7, it's 6, correct? My e2 will be
Yeah.
6. Is my 6 present in my set? Have I seen 6? No, right? So
No.
I will be moving with the next element. But before moving, what is my responsibility? I should be adding 1 in this set. So here I missed one step. That is, we need to add as well. So let's say if this is not the case, then else uh, set dot add e1, and after this ends, return false. Okay, so if this is not the case, we'll be moving with the next element. The next element is whom? 0. So 0 is there and respective guy will be, it will be 7. So is my 7 in my set? No, right? So I'll be moving with the next element. Who is the element? 4. Who is the respective element for 4? It's 3. Is my 3 present? No, right? So we'll be moving with the next element, but before moving, we need to add 4 over here. Now 3. Who will be the respective element for 3? It's 4. Is
4.
my 4 present? Yeah, it's present. So we found the guy. So what will be the time complexity of this code
O of n.
and what will be the space complexity?
O of n.
Correct. Okay. So there is a trade-off that we decreased the time complexity, but our space complexity got increased. Okay. So there will be, in most of the cases, there will be always a trade-off. Cool. Now we are going to do the same question, but this time your array is sorted. On a sorted array. So I hope I don't need to like repeat the input and outputs. Like it's the same question. It's just that now we are going to perform things in sorted array. Yeah, Yaksh, are you having any doubt?
Yeah, I just wanted to know that the last way you solve the problem, is that the optimal way to solve for an unsorted array of n is the optimal time complexity, or we can further
Yeah,
look it up. Just want to know that. Just uh,
yeah, yeah.
that's it, right?
Mhm.
Thank you.
So now let's talk about sorted array. Okay. Now what we can do? Can we do method one that we previously saw? That is brute force. Can we do that? Obviously, we can do that. Correct? Okay. Method two.
Yeah,
Can we do the second method using sets?
yeah.
Obviously, we can do that. Okay. Space complexity, time complexity remains the same. Uh, can we do something else as well? Something else as well. Can we do?
So, we can. I don't know how, but we can use divide and conquer, right? Conquer. So in this,
Divide? How divide?
so we know that the target is already larger, right? So basically, we can skip the mid values. So I mean, we can bifurcate the array in two parts and solve for the other end of the part.
Mm, didn't get the. Okay, let's see. Let's say the target is 7. Now, what you are going to do?
So we have four elements, right?
Mm-hmm.
So we will divide array into two parts.
Mm-hmm.
So 0, 1, and 3, 4. Okay, because we know that the target is quite large. Uh, the summation of
Let's say our target is 4. Now, what you are going to do?
target is 4. Yeah. Okay. So
Okay,
that
let
might.
me tell.
Mhm.
So let's suppose we want to plot the values in a graph. So what you can see, the values are increasing only, correct?
Mhm.
Now the thing is, mm, now the thing is, let's say, uh, what we can do is that uh, uh, we will be keeping a pointer over here. Let's say P2. We can keep a pointer over here, P1. Okay. Now let's suppose P1 plus P2 this is one of the case. Okay, like mm, what is the case? That is P1 plus P2 is equals to K. It means we found our target. We found our target. Okay. Okay. Case 2 is something like P1. Okay, basically it's not, we are not adding just the pointers, the indexes, we are adding the elements. Okay. So P1 plus P2, now let's say is less than target. Now what is the judgment I can make? Okay, now see, if the values which P1 and P2 are pointing is less than less than my target, what can I say? Okay, the current sum of this guy who they are pointing, they are smaller. Then somehow I need to move this pointer somehow so that my sum will increase. Yes or no, guys?
Yeah.
They are pointing to some elements. They are pointing to right now some elements whose sum is less than my target. And if I want to approach my target, I need to improve my sum, right? I need to increase my sum. How to increase my sum? Now let's suppose if I decrement P2, what is going to happen? Will it point to some bigger element or smaller element?
Yeah, smaller element.
Smaller element, which means end result, what will be the end result? That sum is going to decrease. Okay,
Yeah.
sum won't be increasing. So instead of moving P2, what we can do, we can move P1 on the right side. Now what do you think it will happen? It is going to increase,
Increase.
correct? So if this is the case, we are going to do P1 plus plus. Okay, acha. Now the other case, P1 plus P2 is greater than my target. Now if I want to reach my target, what I need to do?
Decrease the P2. I mean, yeah.
Correct, correct. Decrease, decrease. Fine. So if I write the code, it will be something like this. While P1 is less than P2, uh, initialize P1 with 0, P2 with n minus 1. And inside that, you need to write this logic. Okay. If we find this target, then return true. Otherwise, after ending the while loop, you need to return false. So what do you think? How much what will be the time complexity of this code? So do you want me to dry run as well?
Uh, I mean, yeah. Can you just explain the whole
Yeah,
coding
okay.
and thing? Yeah.
Let me do the dry run. So let's say P1 is pointing over here, P2 is pointing over here. Now what is the sum?
4.
Yeah. So and our target is 7. Fine. So 4 is smaller than 7. Now I want to increase the current sum. Whom I need to move?
P1.
Okay. Now P1 is here. Now what is the current sum?
5.
Is it equals to my target?
No.
Is it smaller than my target?
Yes.
So whom I need to move?
P1 again.
Okay. Now what is my sum?
7.
Is it equals to my target?
Yeah.
Yeah, we can return record it. You want to try with some different target? Man?
No, no. I was just saying like the pseudocode you wrote, like
Mhm.
besides
Yeah, yeah, yeah.
while P1 less than P2 and the 3 conditions, right?
Yeah, yeah. Basically, see, it will be something like if array of P1 plus array of P2 is equals to target. Basically,
Oh,
the
oh,
P1 and P2 are indexes, right?
oh yeah, yeah, yeah. I get it. I get it. Yeah, I was just sorry about that. Yeah, I got it.
Yeah, yeah, no problem. Sorry. Pool. What will be the time complexity of this pool?
Uh, it can still be U of n, right? I mean, we still have to traverse through all the elements. So
Correct,
still
correct.
be U of
And,
n.
and space complexity?
Uh, I guess O of 1
Correct.
constant.
Fine. Okay. Mm, Now let's move with some different question. So let's move with searching. now. So we discussed 2 pointers. Let's move with searching as of now. So in searching, what anyone know like what kind of searching method we can do?
One is the basic linear searching,
Okay,
and another one is the binary searching.
okay, and anything else?
BFS, DFX for nodes.
Uh, you are correct. Those are also searching, but those are not on linear data structure. Okay,
Oh yeah, sorry.
uh, like no, you are correct only, but those are on not on linear data structure. But
Yeah,
we are just right now talking about linear data structure. Mhm. Okay, what is linear search?
traversing through the list to get the element.
Correct, correct, correct. Like we are going to traverse through all the elements. Basically, if we will be basically given a target and a list, we need to traverse the whole list to check if my target is there or not in my uh, list. Okay, something like this. If array of I equals to target return 1, okay, else return 0, something like that. And what is binary and what is the time complexity of linear search?
Of
N
n.
What is the time complexity of binary search?
log n.
Yeah.
Okay. So can you tell me what uh, is the idea behind binary search?
Basically, reducing the search in half every time you search.
Yeah, yeah. Go on.
So basically we'll figure out a middle point and then we'll compare whether the element is like lower than the middle point or the higher than the middle point. Then we can, capture our spaces. So whether to look for the left hand side or the right hand side, something like this.
Correct, 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 correct. So what we are going to do, let me just tell you something like this. We'll having a pointer over here. We will be having another pointer over here. Okay, left pointer, right pointer. Using this, we will be calculating a mid. Okay, now we will be checking if my mid element is equals to my target or not. Okay, array of mid is equals to my target or not. If it is so, then return 1. Okay, now the thing is, if my array of mid is less than my target, what it signifies, guys? What it signifies?
That the
Okay.
element is in the left hand side of the array.
So in if you want to apply binary search, if you want to apply binary search, things should be always should follow some kind of pattern. For now, just like I am telling you, you binary search for the first time. So just think array should be sorted. Okay, array should be sorted, but it's not really necessary. It's sorted only. Basically, some kind of pattern should be there. For now, just understand it should be sorted. Okay, now the thing is, yeah, can you please repeat yourself? Like, if it is less than your target, then what you will be doing? Then what it signifies? Your target
So
present
That
on
the
the
element
right,
is in the left hand side of the array.
right answer, right? If it's
right
less
hand
than the right
Oh, is
answer.
it if the target is more than the middle?
I think it's sorted, so I think right answer, right?
Oh, then it should be right hand side. If the target is more,
side.
then it's right hand side. Less, it should be left hand side.
So if it is on the right hand side, then what we should be doing? Now
Increasing
our
the
space,
mid. Sorry,
Doing the same process for the right hand side array, like
increasing
for
mid
the sub array, right hand side sub array.
yeah, yeah. You please tell what we need to do.
m plus plus
Y m plus plus.
on the right hand side. That's why move the pointer.
Uh, mhm.
So
See,
basically, I think Yakshi is trying to say that the left hand side will be m plus one.
yeah, yeah. I
The
mean,
left indicator will be m plus one. Yeah.
I got that. But the thing is, m is not the variable through which we will be finding our target. Okay, like L and R are the important pointers to move to decide the scope of searching. M is just to is a variable just to get the mid
Oh,
of
sorry, sorry. Yeah,
mid of
yeah, yeah. I see. I can see now. Yeah,
yeah.
sorry. Yeah. Okay. So, what is R and L again? I'm sorry.
It is the
Zonal.
leftmost. It is pointing the leftmost and it is pointing the rightmost. You can also
Okay.
say
Okay.
low and high. Anything.
Oh, okay. Okay. So if midpoint is less than the target. Hmm.
So now what we can do, we can move our left pointer. So our search space is whole array right now, right?
Yeah.
Now we
Mhm.
know that definitely our element won't be present on the left side, and definitely m is not the value, because if m would have been that value, then we would have got our answer. So what we can say, our target lies over here. Yes or no?
Yes.
Yeah.
Okay. It means whom I need to shift? We
Left.
need to shift L or
L.
R
Yeah.
left.
L.
Okay.
L.
So L equals to what?
M plus one.
M.
Yeah. Yeah. I can see that.
Okay. M plus 1. Fine. Okay. Another case is A of M is greater than target. Only these three cases will be there. Do you guys agree?
Yes.
Okay. Now what
Yeah.
we need?
We need to shift R now. So R equals to m minus one. Mid minus one basically.
Awesome. So if we write the code, it will be something like this. L equals to 0, R equals to n minus 1. Now while we need to make sure this don't overlap. Okay, so something like this. Now m equals to L plus R divided by 2 if array of mid equals to my target, then return 1. We'll set array of mid is less than target, then n equals to m plus 1, else R equals to mid minus 1. Okay, after we are done with this, we can return. This is the return. Okay, after let's say we are out of this while loop, it signifies we haven't hit this return statement. Correct? It means we haven't found that pair. Sorry, we haven't found our target. It means we need to return 0. Got it?
So,
Is it
uh,
0 or minus one, Rahul?
No, we are just not we are not returning any indexes. We are returning
Oh, okay.
if the target is present or not. If it would have asked about the indexes, so here we need to return that index. That is, we need to return m. Okay, and here what we need to return -1.
Okay, perfect. Thank you.
Do we need a break statement after first if conditional?
No,
Or
no, we are doing a return statement. So if this is the function where you are implementing binary search, it will automatically go out of.
so we'll have
Hello,
variable making the I mean tracing the boolean, right?
sorry, didn't got what you say.
So we'll be having a variable tracing the boolean, right? So it'll be first initialized to zero, and then if we have equals to target, it will be initialized to one, right? That's the thing. And then return that variable.
Not really. Like you can return true and false, something like that. You can decide the boolean. Like you can write that function return type is boolean, something like that.
Oh, okay. Yeah.
Okay. Now let me ask you another question. It's not related with searching. Uh, so let me tell you that one, two, three, four. These are the elements in an array. These are all the elements in the array. Now you need to, what you need to do, you need to print multiplication. You need to create an array, another array where multiplication of every element will be there. So how you will be creating this multiplication is that for index 0, we will be having the multiplication of all the elements, product of all the elements other than 1, other than this element. So remaining elements, if we see and if we multiply, what is the value we are getting? 24, right?
24.
Now, yeah. Now, if we just so other than 2, what is the product of all the remaining elements? It's
12.
12. Okay. Okay. What is the remaining elements? 1, 2, 4, and what is the product of remaining elements? It's 8,
8.
right? And here it's 6. Correct?
Yeah.
Yes.
Yeah. So how you can do it? Any idea? You got the question, right? You will be given an array. You need to write. You need to create this product array. Given that for every element you need to calculate the product, but in that product it should not be included. That particular element should not be included. So can you think about something what you can do? See, one method, one very naive method is what? Brute force. That is, we
Brute
can
force
run
approach. Yeah. Yeah.
two loops. That is uh, 0 to n minus 1 we can go. And for we can have a product equals to 1. We can go from j from 0 to n as well. But only in case of I not equal to j, we are going to do product multiplication equals to array of j. Yes or no, guys? After we are done, after we are done in our answer array, in our answer array at index I, we will be storing this particular product. Do you think this thing work? This will work?
I- Yes, it should work.
Yeah, correct.
No. Uh,
But I
Why?
have a question here though. Isn't the JS should be starting from 1?
Why one?
Because we'll be taking consider the other elements, right? Because we
So let's
shouldn't
talk
consider
about
the
two. Let's talk
actually,
about
yeah. Because you're doing I not equals to J is balancing that out. Yeah, that's okay though. Yeah, that's okay.
yeah, okay.
I don't think it will work. One thing is because we're just moving forward, right? We're not going back. So if you're at the
Really?
index three, yeah,
So for index 3, what is going to happen?
index three, we won't.
I
I
equals to
mean,
3.
I equals to 3. Yeah.
Then
3 is not equals to.
so now wait. Now the product is 1.
Yeah.
J from where it is starting?
I equals to G starting from 0.
0. So what is the value at a zeroth index? It's 1, right? So product will be multiplied by 1 and it will be getting updated the value. The value will be 1 only right now. Now I will be incrementing the value of j with 1. Is 1 is equals to I?
Uh,
Uh,
Sorry, what?
is
It's 1
1
equals to.
is j and I values present in j and I are equal?
No, right? No.
Okay, then what is the value at ith index? Sorry,
2.
jth index?
Yeah,
Jth
2.
index 2. So
Oh,
is
yeah.
it
So, no.
okay?
Okay. Yeah. Sorry. I can see now. Yeah.
Yeah, it's working. It's working
Yeah,
the
it's
whole
working.
process.
It's working. Yeah. Working. Got it.
Okay. So what
Thank
will
you.
be the time complexity?
O1 square.
N square.
Mhm, fine. And space complexity? It's
O of
constant
n.
only. Basically, we need to return this array. So if this array our function demands, we can say it's not a time complexity. Sorry, it's not a part of space complexity. Space something what is part of space complexity is that if something we are some memory, the memory we are creating for sake of our for sake to solve our problem.
So we aren't creating the answer array.
Yeah, because our function requires, okay, our user requires it. It's not because I can't solve
Okay, so
this.
it's passed on to as a
Problem.
parameter. That's why. That's what
Uh,
you're saying.
yeah, you can think something like that. What I mean is that if let's say you are given, let's say uh, you are given something, and if your question demands an array or 2D array or something, anything, those things won't be part of your space complexity because that thing is
Oh,
demanded by your caller.
okay.
you
I
haven't
see now.
created you haven't created those memory to solve your
As
problems.
a part of
Just
solution. Okay.
okay.
Yeah,
Yeah.
got it. Thank you.
Okay, another method what we can do. So let me tell you what we can do as well is that mm, this will be the another method. So here you will be calculating the total product. So what is the value of total product? It's 24, right? Now what you are going to do at every index, you will be knowing what are the values are there. You will be just dividing that by 24 and you will be putting that value respectively. So 24 divided by 1 is 24. 24 divided by 2 is 12, so put 12. 22 divided by 3 is 8. 24 divided by 4 is 6. So are you getting the values? Have you understood what I
Yes.
meant?
Yeah. That's a more
Yeah.
efficient method. Yeah.
Yeah. But the thing is, we are using what we are using. We are using division. So can you do something without using division? Can you do something without using division? Okay, let me tell. So this thing using prefix suffix. What we are going to do? We are going to create two kind of array: prefix and suffix. So in prefix, what we are going to do? What is the agenda? Is that from left to current index, how many elements are there and what is the product? So from left guy to zeroth index, what how many elements are there? Only one elements. That is one. And what is the product? It's one only. Here, if it is one, it means from leftmost side to one, how many elements are there? How many elements are there, guys? Please respond. How many elements
Two.
are there? Two. What are the elements? One and two. What is the product?
Two.
Two. Yeah. Now from leftmost side to this index, how many elements are there?
Three.
What are the elements? One, two,
Yes.
three. What
One,
is
two,
the
three.
product? It's
Six.
six. Here, what are the elements? One, two, three, four. What is the product? It's
24.
24. Correct.
Mhm.
Now we are going to calculate the suffix array. Here we are going to start from the end. So from rightmost side to third index, how many elements are there?
One.
One.
Sorry,
What
four.
is? Yeah. Only one element is there, and that element is four. So product of those elements is four. From leftmost side to second index, how many elements are there? Two, right?
Two.
Three,
Yeah.
four. What is the product? 12.
12.
From rightmost side to first index, how many elements are there? Three elements, right?
Three.
What is the product?
24.
24. And from leftmost side to zeroth index, how many elements are there? Four are there. One, two, three, four. What is the product? 24. Now what we see? Now we are going to calculate our answer. Let's not talk about our leftmost and rightmost. Let's talk about this two guys. If let's say if I want to find for this ith index, if I want to find the product of this guy, product for this guy, what it means? All the elements till I minus one from leftmost side, correct? For all the elements from leftmost side till whom I minus one, okay? Multiplied by all the elements from rightmost side till whom I plus one. Okay, if I multiply this element and this element, so this element, what this element denotes, x, what denotes all the elements from leftmost side to I minus 1 index is x, and what is this value y denotes? This is the product of all the elements from rightmost side to index I plus 1. Now if I want to find the product for I, what will be the value for I? What is the value? It's nothing but x multiplied by y. Yes or no?
Yeah.
Do you guys agree? So if I want to find for 1 from prefix array, can I get 1? Because it means that for 1, if I want to get, I need to get the product of all the values from leftmost side to 0th index. From where I can get it? From prefix array I can get it. Okay. From leftmost side to 0th index, what is the product? It's 1 multiplied by from rightmost side to index which index? Till 2. From rightmost side to index 2, the product is 12. So what is the value we are getting? It's 12. Okay. For index 2, what we are going to do? We are going to do the same thing. Leftmost side till index 1, what is the product? It's 2. From rightmost side to index 3, what is the product? It's 4. Are we doing any mistake? No. It's 4, right? So what is the value we are getting? We are getting 8. See, 12 and 8. Are you getting what I'm trying to say? What I'm trying to convey?
Yeah.
Now for leftmost side and rightmost side, it's trivial that for leftmost side there won't be any left guy, right? There won't be any left elements on the left hand side, correct? Like if I am talking about index 0, there is, this is only the leftmost guy, so there won't be any leftmost part which will be contributing. Every contribution is going to come from the rightmost side. So rightmost side means from rightmost side till index 1, what is the product I can get from suffix array, that is 24. For rightmost index, the same situation, that no one is present on its right, so no contribution is going to come from the right side. Every contribution will be coming from left hand side only, that is from 0 to second index, how many elements are there and their product. From where we can get it? From suffix array, from prefix array we can get it. So it's 6. Got it, right? 24, 12, 8, 6. Can you see? Both are same. Like the answer, we got it. But what will be the time complexity here? Time complexity. First, we are running one iteration to calculate this prefix array. It will be order of n. From here, we are running another loop to get this suffix array. It's also order of n. Here also we are doing order of n only because we already calculated these values. We are not generating these values running a loop. We are already generated this arrays and we are just using, we hash these values and we are using the respective values. So what was the time complexity? It will be order of n. Can anyone tell me about the space complexity?
Often.
Yeah, it's order of n because to solve this problem we are creating two different arrays. Fine. But the what is the important point here is that in interviewer, in interview, the interviewer will ask you to do without division. Okay, then this method will come handy because this is going to take order of n square time complexity. Okay, guys, that's it from my side for today. We can meet in the next session and we can discuss more problem. So, any doubts from today's class?
No doubts. Just wanted to know, like, what would you call the last problem, like, and similar problems, so that I just need to see the code somehow. So for prefix and suffix, what would you call that last problem, like?
Okay, you want link to that problem?
Yeah, probably. Yeah, that will help.
Yeah, me as well, if you can. Yeah.
Because now I understand, but yeah, later, like 1 week after, I need to. Yeah, so I just need to see the code and practice it. Yes. If you can just.
Yeah, for me as well. Like since it's like a new approach for us. So yeah.
Yeah.
Hmm. I'm sharing the link over here. Okay, I have shared the link.
Yeah. Thank you very much.
Thank you.
Sure. Okay, guys, take care. Bye. Good night.
Thanks. Bye.
Thank
Have a good
you.
night, guys. Take care.
Thanks, guys. Bye.